So hello, our names are Ignacio Rodriguez, Luis Sanchez, and Martin Gomez, and we are going to present our NanoStore data analysis project, Visibility of Health Products in Mexico City.
Okay, so our problem statement was that Mexico City faced high levels of overweight and obesity teens and adults. We see that that nano stores and small convenience shops located near schools sell everyday food choices. However, healthy items are often less visible and hard to find, so because they are less profitable and by shopkeepers. So what we see that was ultra processed snack are usually placed in the most visible spot. So our research question was which factors increase or decrease the visibility of healthy products in nano stores around Campus Santa Fe and Campus Ciudad de Mexico.
Okay, so our project purpose was, this project uses structured surveys from shopkeepers to build a regression model that explains visibility of healthy items based on perceived demand, price sensitivity, shelf life concerns, supplier incentives, shopkeeper demographics, and campus location. So the results can guide university, health agencies, and private partners in creating targeted interventions that improve healthy food visibility without ignoring the economic reality of store owners in the country. And we also have our Gantt structure here.
Perfect. So our ETL overview was ETL process follow for a structured workflow, but all assist integration of raw data sources, manual verification of merge to avoid loss of record, recording, validation, and construction of the analytic dataset, and graphical and statistical validation.
Okay, so after we did that, then the treatment we followed for the missing data was that high missing variables were removed, numeric variables were inputted with median to avoid the extreme values, and categorical values were inputted with MOVE. All transformations here were documented in the final deliverable for reproducibility. For the data recoding and transformation, several variables required recoding in the database. Categorical variables were converted to dummy indicators. Range variables were ordered in numeric scales, and text variables that only represented two possible options were recorded with zeros and ones, like campus and yes or no questions. This created a fully numeric dataset, adequate for regression modeling. This is our final dataset validation, the last step in the ETL process. The final data was validated to confirm that no missing values were in selected variables. Outliers were consistent with real conditions. Distributions visually checked using box plots and histograms, and dataset size was sufficient for regression modeling. Here on the right, we have the histograms of the numeric variables and also the count of the categorical variables through bar graphs.
So our variables for our modeling, the response variable was visibility healthy items num, a numeric scale that represents how easy it is for customers to see the healthy products. And all of the predictors in the were narrowed down to the database predictors. So these are our predictors.
So our exploratory analysis, we can see the box plot of change low demand. Before selecting the model described, the statistics were computed. Box plots revealed concentrations around mid-range value of demand perception. Campus distributions, we can see that. And also we can see the reasonably category balance allowed inclusion in the model.
Right. For selecting the model, the team elaborated two different regression models. And the difference between these two was that one used stepwise selection method with an alpha to remove of 0.15%, and the second used a forward selection of variables with an alpha to remove of 0.25. This method ensured that only variables with meaningful contributions were added to the model. As you can see, we have both of the regression modes right here, and we also have the model summary for both of them. And the team used R squared adjusted as a criteria to make the decision. And so we used model B, which has an R squared adjusted value of 39.34%. For the final regression model, the model quality was R squared was equal to 49.21%. The adjusted R-squared, which is what we're looking for, was 39.34%. And the p-value of the regression was 0.001, which means that this regression managed to be statistically significant. As you can also see in the coefficient table, we had no BIF value above 3, which means that there are really no issues of multicollinearity present in the model. And we can also see the p-value of each variable and the summary again. For the residual analysis, the residual plots show that the residuals are normally distributed. As you can see, they follow a straight line. The histogram is roughly symmetrical. The residual versus fits plot shows a linear trend, but really no strong patterns such as what we saw in class, like camel humps or cones, nor any abrupt changes in variability. And in the residuals versus order plot, the point appears random, so there's not really any cycle or trend that happens over time. So we concluded that from this analysis, it is reasonable that the assumptions of normality and independence are actually met quite well for this specific model.
So, which were our key findings? The model suggests that perceived high-price healthy items increases their visibility. Shopkeepers aged 40 to 49 tend to give lower visibility. Shopkeepers with high school completed had an increased visibility, and trade credit incentives positively influence healthy items visibility.
Okay, so our recommendations for the base on the analysis of the regression model, the team can confidently make the following recommendations. Estrangement supplier incentive to boost visibility, provide micro trainings for shopkeepers, especially for ages of 40 and 49, use a premium value framing to improve perception of healthy products, and standardized shelf placement guidelines across stores and franchises.
Thank you very much for looking at our presentation, and we sent you a
Goodbye.